Good morning, good afternoon, or good evening, whichever is applicable to you. And thank you for joining us for today's webinar titled Not Dead Yet, Expiration and Deletion in zOS Tape and Disk.
Datasets, like other organisms, have a life cycle. They are born, live, grow in size, retire, and eventually die. That is, in zOS, they are created, opened, read and written, archived, and eventually expired and deleted. The last of these stages, expiration and deletion, ensures that obsolete data is removed when its time comes and does not take up valuable storage space or get improperly used. In this webinar, we'll explore when and how datasets and volumes expire and what happens when they do. This presentation is sponsored by Precisely Software. Precisely is a recognized global leader in enterprise data integrity products for mainframe, mid-range, and distributed systems. For more information on Precisely, please visit precisely.com. Our speaker today is Principal Technology Architect Steve Pryor. Steve has more than 30 years' experience in storage management, design, and support, and speaks frequently at industry events. Prior to joining Precisely, Steve made important contributions at several mainframe software vendors, designing and implementing major products and components. At the end of the presentation, we will have a short Q&A session. Attendee microphones are muted for the presentation, but you may ask a question or request webinar assistance at any time during the webinar through a Q&A interface. If you encounter any issues where the slides do not show up or they are not advancing, please refresh your browser. That seems to fix most of the issues. After the webinar, all registrants will receive a link to the slide deck and recording. Thank you again for joining us today. Take it away, Steve.
Thanks, Ray. Good morning, everyone, or good afternoon. My name's Steve Pryor. You'll have to excuse me here because the southeastern U.S. this time of year is allergy city, and so my allergies are acting up, and so I may be coughing and hacking my way through this, but hopefully you'll get something useful out of this. What I wanted to talk about today is expiration dates. There are lots and lots of topics in zOS that we can talk about and that we as DTS and then Precisely want to talk about and sort of disseminate our experience across the wider zOS universe. And so one of the sort of interesting topics that people don't pay a lot of attention to is expiration dates. And so I entitled this "Not Dead Yet," and I had it was everything I could do to avoid putting in the Monty Python parrot sketch here. But what I want to talk about is the life cycle of a data set and where the expiration dates and migration attributes come into play during the data set life cycle. And so I'm sure everybody has seen slides like this at some point where, and this is true for throughout data processing, not just in zOS, obviously, but we talk about the life cycle of a data set. A data set is initially created, or typically in zOS terms, we say allocated. It's then opened and used in some way. It's read, it's written. It, it extends to additional space on disk. Maybe that additional space is released if it's not entirely used. But at some point, the data set, during this process, the data set ages. It's initially created, it's born, it grows up, it gets used, and then it ages. And if it isn't used in a while, it enters sort of an old age, and it's taking up valuable disk space, and which could be used by other data sets. And so it's archived off to some cheaper medium, to tape, to disk, to something like, or to tape or cheaper disk. And ultimately, data space isn't infinite, disk space isn't infinite, even tape space isn't infinite. And ultimately, the data set expires and can be deleted. And some data sets have explicit expiration dates in them, or explicit times when they are old enough to be migrated and old enough to expire and ultimately die. And sometimes they're reborn, especially in tapes when they go back to scratch. But I want to talk about some of the phases of the life cycle here that are important for zOS. And so specifically, I want to talk about expiration date. And one of the reasons that we set an expiration date, we don't usually set them on disk data sets, but they certainly can be set. One of the reasons we set an expiration date is to prevent it from being inadvertently deleted or migrated or updated. And so I want to talk first about expiration dates, what they are, pardon me, how they get set. And then we'll talk about what happens to the data set as it ages and becomes migrated and ultimately dies. So where do we get an expiration date? We can get it from a couple of different sources. If we're going to have an explicit expiration date, which makes the data set ineligible for deletion. I said here eligible for deletion, but it really makes the data set eligible for deletion only after that date that we set. And so it protects the data set from deletion or from overwrite. You can't open a data set open for output a data set with an expiration date on it unless you do something special. So initially we might get the expiration date or the retention period, which is the same thing. It's there's ultimately what is stored for the data set is a date and not a number of days. But you can specify in the JCL or in the IDCAM's control statements or wherever we're getting this from, but I want to talk about JCL first. You can specify a retention period, but the way that's calculated is the number of days in the retention period is simply added to the current date. So in the JCL, we can specify expiration date or retention period, or if you've got some older JCL, the expiration date value might be specified as part of the label parameter. And so the label parameter can get really large and complicated, which is why IBM prefers you specify expiration date or retention period as a separate parameter, but you might well have it as part of the label parameter. We could also get the expiration date or retention period from the SMS data class, and the SMS data class applying both to SMS and non-SMS data sets. So if there's a data class present, the expiration date could come from there. But if it's specified in JCL, pardon me, if it's specified in JCL, then it's overridden. Yeah, that JCL value will override any expiration date specified in the data class. And so the expiration date as you specify it can be one of two forms. It can be YYDDD, which is 5 digits, the old expiration date, a year and a date. Nowadays, that's only good for 20th century expiration dates, which unless it's a special date, like 99-365 or 99-366, a never expired date. Hopefully you're not setting expiration dates with a 99 value. Those never expired dates are primarily for tape, 99-365, 99-366. This taped data set never expires until you explicitly expire it. But it'll work for disk as well. But if you specify it in JCL, it's nowadays a 4-digit year followed by a slash followed by a 3-digit day number, which can be anywhere from 1 to 366. If you set the expiration date to some prior date, like 99-200, 200th day of 1999, it's equivalent to not specifying at all. That is, the data set can be deleted immediately. If I specify, 2022/004, I might as well not have specified an expiration date because it's past. I can allocate the data set with an expiration date in the past, but it won't do me any good because the data set will be eligible for deletion. And again, I can specify it as retention period, which is simply the number of days from the creation date of the data set, up to a maximum of 93,000. The reason maximum is 93,000 is, first of all, it's way off in the future. And secondly, anything above 93,000, again, tends to get used for a special purpose date, which we'll talk about with tapes. If it's in label, they didn't change the label parameter, so you can only specify a maximum 9999 in label. But if you specify somewhere, either in the data class or in the JCL, an expiration date or retention period, that value goes into the data set, and we'll talk about just where, and the data set can be neither deleted nor overwritten unless you do something special. So if it's in the data class, this is the value in the data class. And again, you might have an ACS routine that will assign a data class to a non-SMS managed data set. Now, once that's done, the data class isn't stored anywhere, but the expiration date will be stored there. And so you can specify a retention period or expiration date in the data class here. One of the sort of interesting things about that is that if you specify it in JCL or in the data class, and you're allocating a new data set, and you decide to use the values that were established for space parameters and LRECL and block size and things like that by using a refDD parameter or a like parameter in the JCL, the thing that doesn't get copied from the like data set, that is from the model data set that you're using, is the expiration date and retention period. So it's a little bit unique in that if you want an expiration date and you specify like, I want this data set to be just like that data set over there, you still have to specify the expiration date specifically if you want the expiration date. Okay, so data sets expire on their expiration date. The case for usually for VSAM, for non-VSAM, it doesn't matter. But the special case of generation data sets are the generation data set will expire, excuse me, on whatever you specify in the define for the GDG. And so since it's ID CAMs, rather than specifying expiration date retention period in the define, or you can do an alter for in ID CAMs, you have to use a 2 and a 4 parameter, 2 some expiration date or 4 some number of days. So it's the equivalent of expiration date retention period. And I can have an expiration date typically in a VSAM cluster. I might put it probably more so than in a non-VSAM data set. But also I can define, I can put an expiration date in after the fact by using an ID CAMs alter. I can even do it for user catalog. Where it becomes interesting is with GDGs, because there are 2 parameters in the GDG that have to do with dataset expiration and dataset retention. The retention date or the expiration date is in the define, but the other things that are in the define are scratch. That is, when I reach my GDG limit, if I have a GDG with a limit of 100, when I create generation number 101, what happens to generation 1? Does it get uncatalogued? Does it get scratched? If it does get scratched, if it has an expiration date, what happens? Well, if I have defined that generation data set, as opposed to the generation data group, with an expiration date, and the GDG specifies scratch, the system would like to scratch it, but it won't do it. It'll uncatalog the data set, but not scratch it, unless it's SMS managed, in which case it will simply roll it off. It'll still remain cataloged, but it won't be part of the GDG. If I specify scratch and I've reached the limit, but I haven't specified purge. If I have specified purge as part of my GDG definition, then when I create generation 101, generation 1, assuming my limit is 100, generation 1 will be scratched, and only if I specify purge. If I didn't specify purge, it was scratched if it had an expiration date, only if I specify purge. If I didn't specify purge, then it's treated as if I didn't have an expiration. Well, it's treated, the expiration date is honored, and the data set will not be scratched. So GDGs are a little bit of a special case because they have attributes in the catalog entry for the generation data group base. And depending on whether you specify scratch and purge, the data set may or may not be deleted. It may or may not be rolled off. Okay, so there's one other attribute that has to do with expiration dates. And I haven't talked, well, expiration dates and what I specify in the JCL. In the SMS management class, I can specify a retention limit. which is basically a retention period, ret period. It can be no limit, which says I didn't specify it. But if I code, say, a retention limit of 10, what that does is to reduce the maximum value that I can specify for expiration date. It applies only to SMS managed data sets because they're the only ones that get a management class. But if I specify a retention limit of 10 in my management class that's assigned to the data set, and my data set JCL I specified a retention period of 20, then the data set will be retained only for 10 days. And I'll get this message that says data set not authorized to expiration date, specified expiration date reset to maximum allowed, and it tells you what the expiration date is. So if I allocate a data set and I say in the JCL retention period 20, but the management class for that data set has a retention limit of 10, effectively I am limiting all data sets with that management class to a maximum retention limit of maximum retention period value of 10 days. And this is useful for data sets that you only want to keep around for a short, weird period of time, but you still want them date protected. You don't want them to go away before that period of time occurs. There are a bunch of other attributes in the management class, which we'll talk about, that have to do with expiration. And you can set these: expire after days non-usage, expire after days. Expire after days non-usage basically says this is it should expire some number. The data set should expire some number of days after the last reference date. But this is not the same as coding the expiration date in the JCL. These two values in the expiration attributes for the management class apply only when the data manager, FDR or HSM or CA disk, processes the data set. And so it's a little bit confusing, but the retention limit applies to any, pardon me, the retention limit applies to any expiration date or retention period you coded in the JCL. The expiration attributes really only apply at the time the data set is migrated by HSM or FDR. Okay, so let's talk about, I've coded my expiration date. I coded it in the JCL. I specified it in the IDCAMS define. I got it from the data class. Where does it get stored? For any given data set, it gets stored in the catalog entry. It actually gets stored in two places. For disk data sets, it gets stored in the catalog. Actually, for all data sets, it gets stored in at least two places. It gets stored in the catalog entry, and so we have a list cat here for a data set with an expiration date on it. And so one of the things, the catalog contains a lot of information about the data set: what's its encryption key label, what's its storage class and its management class, its SMS attributes. But the other thing that the catalog entry for any given data set contains is the date the data set was created and the date it is to expire, if you specified an expiration date. Otherwise, that value is 0. But it's also stored in a second place for disk data sets. If you do an ISPF 3.2 on this same data set, there are three dates that get stored in the format 1 DSCB, that is in the VTOC entry for the data set. The creation date, and if you ever open it and use it, the last reference date, and then the expiration date if you coded an expiration date. Hopefully those always match. There really isn't any reason they shouldn't match unless you went out of your way to use IDCAMS to change a catalog entry for some reason not changing the format 1. In the event where they don't match, the format 1 DSCB always overrides the catalog in terms of can I delete the data set. So we've got it's this piece of metadata, if you will. The expiration date is stored in two places. For all data sets, it's stored in the catalog. For disk data sets, it's stored in the format 1, that is the VTOC entry for the data set. And for tapes, there's lots and lots of sort of redundant data in zOS for tapes. And so the expiration date, if there is one, and not all tape data sets get one, is stored in the tape label. That is, it's actually stored in the header labels on the actual physical tape or virtual tape, depending on whether it's physical or virtual, but it's stored in the tape itself. It's stored for the volume. A volume in when we talk about tapes, volumes get expiration dates as well as data sets. And so in the tape configuration database, which is a special VSAM catalog used to keep track of tape volumes, but not data sets, there's an expiration date stored in the TCDB for the volume. But more importantly, there are two places where three places now: the catalog, the tape label on the data set, that is on the tape itself, and in the tape management system database. And so here we have an RMM entry, and somewhere here we have the create date and the expiration date for that tape. There can be an expiration. Pardon me. There can be an expiration time, but that's not really used. Is not set by. It's set by the tape management system for migration for vaulting purposes. But the expiration date one specifies in the JCL is stored in the tape dataset record, and so we have here a tape dataset record for a particular GDG, and we see an expiration date in there for the particular tape data set. So there's a bunch of different expiration dates we can talk about, and a bunch of different locations where the expiration date can be stored. When we talk about it being stored, it's always an expiration date. It's never a number of days. So we've got the catalog entry for each data set. For disk data sets, the format 1. And for tapes, the tape label and the tape management system record for the data set. Okay, if we need to alter an expiration date, IDCAM's alter, we can do an IDCAM's alter. If I wanted to alter a data set to keep it for a really long time, I could say alter whatever the entry name is, whether it's a VSAM data set or non-VSAM data set or even a user catalog, to some date, which because it's IDCAM's, the format is slightly different. In this case, I want to keep it to the 199th day of 2065. Hopefully, we'll actually delete it before that, but that's how long I'm going to keep it. Or maybe I just want to keep it for 100 days. So this is a retention period value. For IDCAMs, if you're going to do an alter of an expiration date rather than define a data set with an expiration date, and that expiration date is less than the current date, you'll get an error if you're trying to do an alter, IDCAM's alter for to change an expiration date. So you can't get rid of an expiration date by altering it to something less than the current date. And also for IDCAM's alter, IDCAM's is smart enough to look at the management class for a data set, if it has a management class, and honor the retention limit. So if I say for 100 days for this alter the data set, retention for this data set to 100 days, but my management class retention limit says 90 days, then I will get that same warning message that says, oh, well, I altered it, but only to 90 days. Another sort of way around this, actually, is to, you can do an alter of, assuming you have authority, you can do an alter of the management class name for a data set. So, and this will affect how the data set is managed by HSM and FDR, and potentially what its expiration date is if you want to do an alter of the expiration date or retention period. So there's really a couple of different IDCAM's alter commands that we could use that have the potential to affect when the data set is expired, and ultimately then when the data set can be deleted. So eventually data sets age. They get used, they reside on disk for a while. We're primarily talking about disk here, but we can talk about tape as well. The data set gets used, and now it's taking up disk space, and nobody needs it because it's fulfilled most of its use. But perhaps we might need it in the future, so we want to remove it from disk, but we probably want to leave it cataloged so that someone can recall it merely by reference to it. And all of the major disk management systems, FDR, HSM, have this capability to say, this data set's too old, I'm not interested in it anymore. Put it on tape and expire the tape at some point in the future. But put it on tape, delete it from disk, but leave it cataloged so that I can recall it by reference. So we have The DASD management systems, we're talking about FDR or HSM or CA disk, all implement a storage hierarchy in which, as data sets age, they move off of primary DASD, which HSM refers to as ML1, ML0, and you don't see quite as much data sets being moved off to compressed DASD on migration level 1, because that's really been superseded nowadays by virtual tape. But it is possible to archive data or to migrate data, to use the HSM term, to migrate data off of primary DASD and to put it onto either compressed data, compressed DASD, or more commonly nowadays, to archive it to tape, which is what HSM refers to as migration level 2. The idea being that it's cheaper to store stuff long-term, and it still is cheaper to store stuff long-term on tape than it is on disk. And so periodically, the DASD management systems will go and scan the disks, and they will do what HSM refers to as primary space management, or what FDR does with batch jobs. They'll scan the disk and say, let me look at each data set, see how old it is, see if it's expired, and either delete it, or if it's just old age and it's not dead yet, if it hasn't reached its expiration but it's old enough, I will archive it onto tape, and then ultimately that will free up some disk space. Ultimately, I will need to recycle those migration tapes because data will age on the tape as well as it ages on the disk, and ultimately I have another process in the DASD management system that goes through the tapes and says, for each data set on the tape, are you expired yet? Can I delete you? I will then recycle the tapes and drop out those data sets that have reached their expiration date. And so we have a couple of different criteria that can be used by the DASD managers, by HSM or FDR, to select which data sets should migrate off of level 0 and which data sets should be recycled off of level 2. And those can be either SMS criteria, that is the criteria in the management class, or they can be non-SMS criteria, where I say this data set expires after this number of days. An expiration data set is a non-SMS criteria. Or I can select data sets that perhaps are not cataloged or for other reasons. But I have either SMS or non-SMS criteria that will select data sets to be moved from primary disk off to tape, and so on. So let's look at that management class criteria. For SMS managed data sets, we've kind of looked at the expiration attributes, when data sets are considered to be expired. They're considered to be expired because the DASD manager will come along, typically daily, and look at every data set on every volume and say, are you expired? If you are, I can delete you. Or if you're not expired but you're old enough, I can migrate you. So there's two sets of attributes that we look at from the point of view of the DASD manager. We look at the expiration attributes in the management class, and we look at the migration attributes in the management class. And we looked at the expiration attributes a little earlier when we looked at the first part of the management class, and it said expire after days non-usage or expire after some date. So those expiration attributes in the management class are equivalent to coding an expiration date or retention period. So if the management class expiration attribute says expire after 100 days, then the data set is simply deleted from disk. It dies after 100 days when the DASD management system processes it. The migration attributes are a little different. They're actually on page 2. The management class has a lot of information in it, and so this is page 2 of 8. The management class attributes say, when can the data set migrate? That is, when can it be moved off of expensive primary disk onto tape? So when can the data set migrate? There's a couple, so there's a whole set of migration attributes, and then there's a separate set of attributes for what the DASD management system is to do with the GDG, or a GDG generation. So the migration attributes, there are 3 of them, really. Primary days non-usage. How long can this data set remain on disk before I can move it to tape. And this one has very short retention because it remains on disk. Any data sets with this management class named man2 will remain on primary disk only for 2 days. And then they will migrate to level 1 for 60 days. And then they will migrate to level 2, and they can stay there indefinitely until that tape expires. And so we have the management class is for use by the storage administrator and ultimately by the DASD management program to determine what happens as a data set ages. And GDGs, like everything, as we said earlier, GDGs are a little bit of a special case. So there's a couple of management class attributes in the GDG to say what happens to a GDG when it ages. How many GDG elements do I leave on primary? That is, if I specify, if I have a GDG with 100 generations in it, I don't necessarily need all 100 to be on disk. I can migrate them off to tape. And so the number of GDG elements on primary is how many disk generations, how many generations I can leave on disk. If I leave 2 generations on disk, if I want to go back to the 3rd oldest, 4th oldest, 5th oldest, I can do that. They're on tape, but this says how many to leave on disk. And then the rolled off GDS action, we sort of talked about a little bit about if I have a generation data group that specifies scratch, when a data set is rolled off, and it doesn't have an expiration, or it has an expiration date, doesn't have purge, but when a generation rolls off, I've created generation 101, and I've created generation 101, generation 1 rolls off. If I haven't specified scratch, that generation 1 isn't scratched. What do I do with it? The management class tells the DASD management system what to do with it. You can migrate it, or you can expire it, or you can do nothing. You can just leave it on DASD. So, and then the management class, as we said, applies to SMS managed data sets. What about non-SMS data sets? We have to be able to determine, as a DASD manager, we have to be able to determine what do I do with these data sets that are aging, that don't have an expiration date, but they are aging. I want to do something with them. They are old age. I want to migrate them. When do I migrate them? For HSM, that's done by a set sys value that you specify in the HSM, in the HSM control statements, or there are set sys values or volume values that you specify in HSM. How many days should a data set remain on ML1, or how many days before it can migrate to ML1? So non-SMS managed data sets are aged somewhat differently in HSM and FDR than SMS managed data sets, where each data set is controlled by its management class. For a non-SMS data set, its aging is controlled by the variables you set in the DASD manager, whether it's HSM or FDR. Okay, so and just an illustration of that. This is a simple illustration of FDR, or it could be HSM. You've got for FDR, HSM has a started task that runs periodically and does something called primary space management, where it goes across the disks and looks at all the data sets and determines which ones, based on their management class or based on other attributes, should be archived or should be deleted. FDR does the same thing, but it does it with batch jobs. And so this is a sample batch job. In this case, the FDR control statement is dump type equal arc. And for those data sets that are not SMS managed, if they are more than 10 days old, there's a parameter in FDR that says a days equal 10. I want to go and remove those data sets from disk and put them onto tape. And so they go to a migration tape. And that tape itself has an expiration, and the data sets will ultimately be deleted when that tape is expired and returned to scratch. The other attribute we've got in here for FDR is I want to remove from disk any data sets that are marked as having been expired. How are they marked as having been expired? They've reached their expiration date in the Format 1 DSCB or in the catalog. And so this part of DASD management, the aging part of DASD management, typically runs every day to either archive data sets or to delete them when they've reached their expiration data set. Expiration date. And so now we can talk about, we've talked about expiration dates, and we've talked about migration, what happens as data sets age. Ultimately, we don't want to keep every data set around forever, despite what the lawyers will probably tell you. Ultimately, we want to take data sets and have them deleted at some point, so they don't take up space on disk, they don't take up space on tape. We don't have to continue tracking them. And so when does a data set get deleted? Well, most commonly it gets deleted at the end of the step because you've coded a disposition in the JCL. Disposition equal new delete, disposition equal old delete, whatever it is, or the equivalent if you're doing a dynamic allocation, you're doing a TSO allocation, whatever disposition you specified in the JCL for the data set, the data set will get deleted there if the disposition is delete. If it's not delete, a data set might be if the disposition isn't delete, the data set might be explicitly deleted, either via IDCAMs. You're running program IDCAMs and specifying a delete command. You could be specifying a TSO delete command, but if you're specifying a delete command in IDCAMs, ultimately that will cause an SVC 26 to be issued, and SVC 26 is the delete SVC, and if the data set has not expired, it will be deleted. If it has expired, excuse me, if the data set has expired, it will be deleted. But what about a data set that hasn't expired? We have to take a special action for that. We have to specify on the IDCAMs delete, we have to specify purge. I'm going to override the expiration date. The same thing applies to a TSO command, or if you're deleting a data set via PDF, it will issue an SVC 29, which will delete the data set, assuming that you specify, if the data set has not reached its expiration date, you have to specify purge on the delete command. There's also a program that hopefully no one uses anymore called IHprogam, which used to be the way to do sort of mass deletions of data sets. It will go out and explicitly delete data sets it's a batch utility. It's deprecated now. But usually the way the data sets get deleted, if it's not by disposition specified in the JCL or by some explicit delete, the DASD management utilities will delete it. So the DASD management utilities will either archive it or they will delete it. And so the archive utilities or the deletion utilities run for FDR ABR. It goes by the rather grand name of Super Scratch, which will delete any data set that is old enough in terms of the management class or which has reached its expiration date. If you want FDR or HSM to delete a data set that has not reached its expiration data set, you can do that. But again, just like IDCAMs or ISPF, you have to specify a particular parameter that says, I want to delete this data set even though it has not yet expired. And of course, you have to have ROCF authority to do that. So let's talk a little bit about the various ways that one might delete a data set. I can say in the disposition, disposition equals, there are three dispositions. I can specify the status disposition, is it new, is it old, and then a normal and an abnormal termination. So what happens, does the data set get deleted or kept if the step terminates normally, or does the data set get deleted or kept if the step terminates abnormally? And what happens if you have a retention period specified? If I have a retention period specified and I specify a termination disposition of delete, either so I've got disposition new delete, something like that, and I would like to delete it if the expiration date is not reached. I can specify I can specify that if I specify new delete, then the data set will actually be deleted. even if the expiration date hasn't been reached, because I've just created it new in that step. I'll get a warning message that says, hey, expiration date for data set was overridden during delete processing. But if the data set is new and the termination disposition, either the normal or the abnormal termination disposition is delete, then even if the expiration date I specified hasn't been reached, it still gets deleted, which makes sense. I just created the data set. I'd like it to stick around forever, but I specified in the termination I'd like to stick around for some period of time, but I specified in my termination disposition delete. Well, that's going to override the expiration date, as one might expect. But if it's not disposition new, it's disposition old or share, and I specify delete, then it only gets deleted at end of step if the expiration date has passed, as you might expect. And you can't get around it by specifying a new value in the JCL. You'll get an error that says, hey, I couldn't delete this data set because I'm not going to allow you to, the expiration date hasn't passed. And it will give you a rather cryptic error message, which you have to look up, because it's return code 84, reason code 0, which says it's a disposition old data set. You specified delete, but the expiration date hasn't passed yet. So JCL disposition works according to what one of my computer science professors used to say, the principle of least astonishment. That is, it works more or less the way you think it should work. For SMS management class, we're talking now about data sets without an expiration date. When does SMS expire a data set, and that is delete it during either primary space management or secondary space management, that is management of data sets that have been migrated, or a couple of the other times when HSM might get control. It runs at intervals, so what's called interval or demand migration, or during HSM recycle. We pay attention to these attributes that we saw before, not the retention limit, but when should the data set expire? When can it ultimately die? It can die, in this case, after it's been unused for 100 days. And that applies regardless of whether it's on primary DASD initially. If it's on primary DASD, I might just delete it. But if it's been moved off the tape, I can delete it at recycle time. The same thing happens with FDR. FDR has a dump, the scratch routines in FDR run when you specify dump type equals scratch. FDR by default does not pay attention to the management class. It uses the non-SMS attributes you specify in the control statements, like A days. There is a parameter you can specify to say, I want FDR to pay attention to the management class expiration attributes. And so the management class if you're doing that, then the data set, again, will be expired after some number of days non-usage, either at the time after ABR dump runs or when FDR ABR recycle, FDR ABR T-cell runs. And of course, there are non-SMS attributes for ABR, for HSM as well, delete by age or delete if backed up, because there isn't any management class attribute for data sets, non-SMS data sets, because they don't have a management class. Okay. So if I want to delete or overwrite an unexpired data set, leaving the DASD managers out of it for the moment, as we said, data sets can be deleted at disposition time by the old delete parameter, or I can have an explicit IDCAMS or TSO delete command, and if I want to overwrite or delete that unexpired data set, I have to specify purge. Otherwise, we'll just get an error. Same thing happens on ISPF. It gives me an option to put a slash in there to purge the data set. Similarly, if I'm an assembler programmer and I actually call some of these scratch macros or SVCs explicitly, the scratch macro invokes SVC 29, there are parameters I can code on the scratch macro to say, I don't care about the expiration date, purge the data set anyway. And for GDGs, of course, whether or not that data set expiration date is honored when the data set is scratched as a result of rolling off of the GDG base depends on whether the GDG had the purge attribute, or if you're deleting the GDG generation explicitly with the delete command, you can specify purge. Okay, there's several parm lib options that have to do with expiration dates and retention periods and migration. One of the interesting ones is in IGD SMS00. So this is the SMS member therefore anything you put in IGD SMS00 is going to affect every SMS managed data set. And so I'm not sure how often this is used, but you can specify override expiration date, yes or no. The default is no, which says ignore any expiration date for a disk data set. Honor a disk, or at least when you're doing it via disposition. Honor a disposition of delete, even if the expiration date has not been reached. This is useful if you don't think you should have any disk data sets with expiration dates on them. This used to be used also for something called tape mount management, where short retention tape data sets were redirected to disk. And so if you specify in IGD SMS00 override expiration date, yes, and you can then go and delete a data set, even if it's got an expiration date, and you'll get this IGD 17042 message that says, I deleted it anyway. There's in Alex00, there's a sort of a little known little known attribute called 2-digit expiration date policy, which says if you code 99200 or 99300, do I allow that, or do I always have to have a 4-digit year and 3-digit day? So the default is I can code 99200, 99300, 99365, or I could say I want a warning if someone's using the more antiquated JCL, or I could, if I really want to be draconian, I could fail. And if you want 99,000, which says for a tape data set, keep it as long as it's cataloged, you have to specify 1999/000. So the 2-digit expiration date, whether or not 2-digit expiration dates, that is 2-digit years, are allowed, is controlled by Alex00. There's a dev sup member which says, do I want to issue this IEC 507D if I'm trying to open for output a non-vSAM disk data set that hasn't expired yet? And so the default is if I'm trying to overwrite a non-vSAM data set on DASD, I'll get an error message to the operator. And so, yeah, they love that. But if I'm trying to overwrite a non-vSAM data set that's not expired, the default is to get this message, but it can be suppressed. And then the GDG defaults as to whether or not purge is implied when you define a GDG, or whether or not scratch is implied when you define GDG as an IGG cat member. So there's 4 different ParmLive members that have to do with this whole when does a data set get old enough, when does it expire, when does it die. And so we haven't talked about tape data sets, but tape data sets and tape volumes also expire. Tape processing can be a little bit complicated because the tape metadata, data about data sets, data about volumes, is kept in multiple locations. For any data set, there's potentially an expiration date in the user catalog. For tape data sets, there are 2 types of records that are kept in the tape management system data set or database. There are data set level records that tell me about every data set on every tape and which data sets extend to additional tapes, and there are volume records which tell me about all of the data sets on that particular volume. Does this volume span to another volume? What's the data set on the volume with the longest retention period, and so on. And then there's another metadata repository, the TCDB, or what's called the Volcat, which has volume records for SMS managed tapes, which duplicate really the volume records in the tape management system, for how long should I retain this tape, what's the maximum retention period of this tape. And then for virtual tape systems, there's also a device inventory. The device contains the virtual tapes, and of course, the tape labels and the expiration dates for the tape labels are on the virtual tapes. And they're also in the volume records in the device inventory, and all of these have to be maintained. So when do tape data sets and tape volumes expire? Well, fortunately, for the most part, they expire on the retention period that was in the JCL. And that's written to the tape label at the time the data set is created. But that can be overridden. There are retention data sets that contain policies that will override the value you might specify in the JCL. So in CA1, there's a retention data set. In TLMS, there's a what's called the retention master file, and these contain, and RMM, there are VRS policies, virtual vital records policies, that say, well, regardless of what the user might have specified in the expiration data retention period, for this particular type of data set, this particular data set name, mask, or whatever, the expiration date I specify, expiration date policy I specify here, will override that. And that's also then reflected in the tape management system. So there are two places where tape data sets might get their retention. One is from the JCL, which is most common, but for certain data sets, there might be a retention override. And for tape data sets also we may want to retain them in different ways than we do disk data sets. 99, 365, and 366 are, of course, permanent retention. There are other special expiration dates that one can code in the data set, in the expiration data retention period in the JCL or in the retention data sets, to say 99,000. I want to keep this tape around, or I want to keep this data set around, rather, as long as it is cataloged. And the tape management system keeps track of, is this data set still cataloged? And there's a cleanup job that will run every day that will then delete data sets that are expiration date 99,000 or retention period 99,000, but are no longer cataloged. 98,000 is a special case for ignore the tape management system. This is a foreign tape. And then CA1 and TLMS have a bunch of sort of special case retentions for 99,001 to 99,364. Retain a data set for this number of cycles. And 98,001, 98,364 retain the data set for based on the last used date rather than the creation date. So a tape data set will expire basically on one of these three retention periods: the special retention period, or whatever other value you code in the expiration date or JCL in the JCL, or on the retention override. So when can I get rid of the volume? Because for a tape data set, that volume has to die as well at some point. And so the volume retention is typically based in, and this is something you set in the tape management system, on either the first file on the tape, or more commonly, the file on a multi-file tape that has the longest retention. Or for HSM or FDR tapes, those are going to be managed by HSM or FDR as an external, if you define those HSM and FDR to the tape management system as external data managers, and the retention of the volume is under FDR or HSM control in that case. Okay, so when the tapes get, we've talked about life and death. We might as well go, get sort of Eastern here and talk about rebirth and reincarnation. And when does a tape expire? Well, it expires, as we said, when all the data sets on the tape expire, and the tape then gets returned to scratch. And so there are batch jobs, TMS clean for CA1, EDG housekeeping for RMM, that will go through the tape management system records and determine whether there are any tapes left on any data sets left on this tape which have not expired. And if all the data sets on the tape have expired, then the tape is returned to scratch by marking it as a scratch tape in the tape management system database. And there's usually also another job that runs based upon the TMS clean output that will update the tape status from non-scratch to scratch in the device inventory. And there's usually an exit routine that will do that as well. Okay, and so where is all this documented? It's documented in the JCL reference, lots of actually information in the JCL reference, in the IDCAMS manual, and in a couple of other manuals here that you might want to look at. At this point, we've got just a few minutes left, so I'll leave it open for any questions for a couple of minutes, and then we'll talk about next month's webinar.
Well, we do have one fairly larger question here. It says, in our FDR environment, no HSM, there are a lot of GDG generations that exist that are outside the number for the GDG limit. For example, limit set to 10, and you'll have generation 10 to 19.
Right.
And, I'm sorry, 100 to 109. And 95, 97 still in existence.
Right.
It's very common in this environment, lots of extra generations. Let's see. Some on BASD and some on PMM volumes and some on virtual tape.
Okay.
So how do these generations still exist? They're supposedly rolled off.
Well, if they get rolled off, if they get rolled off, depends on whether you've got purge specified for the in the GDG base. If you don't have purge specified, or scratch and purge rather, scratch more so than purge, scratch will cause the generation to be, if it's SMS managed, well, even if it's not SMS managed, scratch will cause the generation, the GDG generation to be scratched, deleted as new generations are created. So you want to first of all, make sure that you got scratch in the GDG defined. Secondly, purge in the GDG defined in case those are expiration date protected. The other thing you might want to look at is whether you're specifying cat limit GDG in your FDR archiving. FDR will, that's the equivalent in management class, in the SMS management class, which FDR doesn't normally pay attention to, of how many generations to keep on disk. So you might look at cat limit GDG, the cat limit GDG parameter in the archive dump job. Those would be the places I would look. You also will look for it in the FDR T cell if you want to make sure that they get deleted off of the tapes to be recycled. There's an equivalent parameter which escapes me somewhere in FDR T cell, but cat limit GDG is probably the thing you want to look at for FDR. Other questions?
Somebody had a comment here too. He said that when he found users were deleting specific generations, not the latest one, and it was breaking the sequence.
That would do it too.
That
yes.
that caused odd things to happen.
Yeah, because if that happens, and that's sort of more of a RAC-F issue, I think, whether users should be able to delete them. But yes, that will cause the catalog to sort of lose track of how many generations are in the GDG base. And I can, particularly for non-SMS GDGs, I don't think it's quite so bad for SMS managed now, but that can happen. Yeah, that could also cause generations not to be deleted when they should be. Next month, I want to talk about encryption because that's a fun topic. IBM pervasive encryption has been around for a while, or IBM's been pushing pervasive encryption for a while. The idea that data should be encrypted not only when it goes offsite, but when it's at rest in your own data center. And IBM is extending this now. The idea that everything should be encrypted everywhere to even so far as the channels, any data set, the products that aren't going to support channel encryption. Well, products need for the next version of ZNext, which would presumably be the Z18 or something like that. IBM is requiring that products that move data around support encrypted FICON channels. And so that's one of the ways that pervasive encryption is extending throughout the universe, to disk, to tape. Everything is going to get encrypted. And so it's important to sort of understand the idea of encryption without necessarily getting into the white lab coat business of which encryption algorithms are secure and which are not. We can talk about how encryption is used and why it should be used as widely as possible. So if you're interested in looking at DTS software products, of course, we've got those. This is the new place where everything is maintained. We've got either a QR code and a URL link there for the DTS content. So if you're looking for ACC or SRS or Easy Exit or all of our other DTS products, they're now part of the SyncSort storage management family, and we'll be glad to talk to you about those. And that's all I have for this week, Ray.
Yep, that's all we had for questions as well. So thanks everybody for joining, and we will see you at the next one.
All right, thanks everybody.